Hi everyone and welcome to the internet. What we're going to be doing today is learning how to calculate the relative formula mass of chemicals. So to start us off, 3 questions on the board that hopefully recap some of the work you did back in C1. So I'm just going to give you a couple of minutes to have a go at answering those questions in your book for me. If you still need a bit more time, then just pause the video now. Okay, so let's mark our answers then. So in terms of the structure of the atom, hopefully you've got something like the picture on the right hand side there. If you've got it right, give yourself a tick. If not, look where you went wrong and correct it. The 4 scientists that were involved in coming up with our structure of the atom were Dalton, Thomson, Rutherford and Bohr. Give yourself a mark if you got all 4 right. And then the third question, what did they do? With Dalton, he said they were tiny indestructible spheres and different elements are made up of different atoms. Thomson said that atoms contain electrons, but the overall atom is neutral. So he came up with that plum pudding model. Rutherford disproved the plum pudding model, and he actually said that atoms have a positive nucleus. He was the guy that did the gold foil experiments. And then finally we've got Bohr, who said that electrons occupy fixed energy levels around the nucleus. Start us off then, we've got 2 diagrams on our screen. What I want you to do is just jot down in your book what you can say about the mass of the atoms in those 2 different diagrams. So just 30 seconds to have a go at that. Hopefully what we came up with was that the atoms on each end of that seesaw must have the same mass because it's balanced. Just jot down in your books then, why don't we measure the mass of atoms in grams? Literally just going to give you 10 seconds to get that done. Hopefully what we said there is that the atoms are actually so tiny that using grams would be rather ridiculous, as we'd end up with a number that would be 0.00000 and just keep going with those zeros for quite some time. So if we can't use grams when we're talking about the mass of atoms and so forth, then we need something else. And what we actually do is we're using something called a relative mass. And by that we mean that we're comparing the mass of that particular item to something else that's similar. Now, if we're talking about the subatomic particles, so the protons, the neutrons and the electrons, then they have relative masses that are compared to the mass of a proton. So they're all relative to each other, so we don't end up with really silly numbers. If we're talking about our relative mass of an atom, also known as the relative atomic mass, which you can see is given that symbol of A with a lowercase r to the bottom right, then what we mean by that is that it's the mean mass of an atom of an element that's compared to 1/12 the mass of an atom of carbon-12. So what we're really saying there is that we're going to compare all of those atoms of all the different elements to a single atom of carbon-12, and we can divide the mass of that single atom of carbon-12 by 12 to then get it. So the relative atomic mass is the mean mass of an atom compared to 1/12 the mass of an atom of carbon-12. Make sure you've got those definitions written down. I'll just give you another 30 seconds in case you've not got it yet. So what we've got on the screen now then are 3 sentences that I want you to have a go at filling in the missing words. So write those down in your book, filling in the blanks, hopefully using a little bit of our common sense and logic to do that. Let's just check our answers then. Obviously, tick any you've got right. Carbon has a relative atomic mass of 12. An atom with a relative atomic mass of less than 12 is lower than the mass of a carbon-12 atom, and an atom with a relative atomic mass of more than 12 is greater than the mass of a carbon-12 atom. Obviously, you can use alternative words for less and greater and so forth. If we just take a moment to go back to those diagrams we started the lesson with, we should now be able to add a little bit more detail to an answer. So again, I'm just going to give you a little bit over a minute just to have a go at saying what we can now say about the mass of the atoms in each of those 2 diagrams. hopefully what we said is that the diagram on the left, then our little red ones, the heliums, are 1/3 the mass of carbon. And on the right, we would say that our carbon atoms on the right hand side of that diagram are 1/4 the mass of the one on the left there. So what I've got for you there is a chemical formula. What I want you to do is in your books, write down everything that formula actually tells you. So I'm going to give you about 60 seconds to write down anything at all you can in bullet points. Then I'll run through what we actually can see from that formula. Now, hopefully you've got some of these on your list. Obviously, tick anything you've got there. We could have said that it is made of 3 different elements. We could name them as hydrogen, sulfur, and oxygen. We could have said that there are 4, 5, 7 different atoms that make it up, which are made up of 2 hydrogen, 1 sulfur, and 4 oxygens. And we might also have said, if you're being really smart, that it is sulfuric acid, so we can work out the actual chemical. Now, when it comes to us writing a chemical formula, then there are 4 really important rules that we've got to follow. So these are our 4 rules here. Make sure you've got them written down, highlight them then, stick them in a box, do something to make it stand out. Our first rule is that anytime we see a capital letter, then that shows us we've got a new element. So whenever you write a symbol for an element, it must start with a capital letter. The second rule is that the number to the bottom right of the symbol tells us how many of that element are present. And this is something people mess up quite a lot. They put that number in the top right or just write it on the line. It needs to be in that little subscript, the bottom right position. Third rule is that a number in front of the formula tells you that there are that many molecules, so the whole chemical, there's that many of them. And then finally, our fourth rule is a number after brackets tells you to multiply everything inside those brackets by that number. So if we had like OH2 in brackets and then a little 3 outside it, then we'd have to multiply the OH2 by 3. So there's 3 OH2s is what it's telling us. If you still need a bit more time to write down those rules, then hit pause on the video now. Okay, let's have a little bit of practice at just writing some chemical formulas and identifying elements from their formula. So have a go at finishing off that table in your book for me. I'm just going to give you a couple of minutes to do that. If you still need a little bit more time, hit pause on the video now. So hopefully by now we know what the relative atomic mass is and how we can find it on the periodic table. What we now need to do is understand this phrase relative formula mass. When we're talking about the relative formula mass, that is the mean mass of a unit of a substance compared to 1/12 the mass of a carbon-12 atom. You may also see this being used in the term of relative molecular mass, which basically just is used to describe substances that exist as molecules. But it's the same thing, it's the 1 unit of a substance compared to 1/12 the mass of a carbon-12 atom. So make sure you've got those definitions written down in your book. I'll give you a few more seconds, but if you still need a little bit more time, I'd suggest you pause the video now. So when we're asked to calculate or work out the relative formula mass of a chemical, basically we just add up. Because all we need to do is add up all the relative atomic masses of the elements that are present together, and we then have our relative formula mass. Let's take a look at an example then on how to do this. So our question there, calculate the relative formula mass of magnesium hydroxide, and then we've got its chemical formula next to it. So the first thing we're going to do is write down the relative atomic mass for each of the elements in the compound. And remember, we can spot them by looking for the capital letters. So we've got a capital M and a lowercase g, so that's one element, which is magnesium. We've got a capital O and a capital H, so we've got oxygen and hydrogen. If we look at the periodic table, and there's a copy of that on my website that you can get, then magnesium has a relative atomic mass of 24.3, oxygen is 16, and hydrogen is 1. So the next thing we need to do is look at that chemical formula and see how many of each atom are present for each element. So if we look, magnesium has no number after it, so there's 1 magnesium. If we look at the oxygen and the hydrogen, you can see they're in brackets there. And what we said was, if we've got brackets, then the little number to the bottom right multiplies everything inside by that. So we've got a little 2 to the outside there, so that means we've got 2 oxygens and 2 hydrogens. The last thing we need to do then is we multiply our relative atomic mass for each element by the number of atoms of that element, and you just add them all together at the end. So we've got 1 magnesium, so 1 times 24.3, and then we're going to add our 2 oxygens, 2 times 16, and we add our 2 hydrogens, 2 times 1, which gives us a relative formula mass of 58.3. So make sure you've got that example jotted down so you can see the stages. If you need a little bit longer to get that done, then hit pause on the video. Okay folks, your turn. There's 3 chemical formulas on the board there. I've given you the relative atomic masses underneath. Work out the relative formula masses for those 3 chemicals. I'll just give you a couple of minutes to get that done. Now, what we could be asked to do is use a chemical equation like the one we've got here in order to actually work out an unknown mass. Now, what we need to know then is a real basic rule, and that's given to us at the bottom here, that the relative formula mass of all of the reactants must equal the relative formula mass of all the products. So by that, what we mean is everything on this side, if we add up all their relative formula masses, must come to the same total as all of the relative formula masses we've got on the other side of the arrow. So let's have a little look and see if this works then. Now, carbon, we'd look it up on our periodic table and we'd find that its relative atomic mass is 12. So we'll start off by putting our 12 in there. Oxygen, we'd look on the periodic table, we find that has a relative atomic mass of 16, but that little 2 there means that there's 2 of them, so 16 times 2. Then on the other side, we've got 1 carbon, because there's no number down here, so there's just 1 carbon, and 2 oxygens, so it's got to be 12 plus 16 times 2. Now, if we just work out the bit in the brackets first of all, 16 times 2 is 32. And then we do the same on the other side, 12 plus our 32, because it's still 16 times 2. And then you can add it together. So 12 plus 32 is 44. And on this side, 12 plus 32 is 44. So we can see that these two numbers are the same. So what we've got is the sum of our relative formula masses of all of our reactants, this bit, is the same as the relative formula masses of all our products. Now in this case we only had one product, but they could give us a question where there'll be a missing product, and that's what we're going to have a little look at next. So let's have a little look at this example then. So what we've got is our equation, but you can see we've got an unknown chemical, we've got X. So they could ask us to actually work out the relative formula mass of X. So we do this in exactly the same way. We look at our periodic table, and for our acid first of all, hydrogen has a mass of 1 on the periodic table, and our chlorine is going to be 35.5. Then we've got our sodium, which is 23. We've got 1 oxygen and 1 hydrogen. So this is what we're going to start off with on our reactants. So we then do the same thing for the chemicals we've got on the right. So sodium is 23, and we've got our chlorine, which is 35.5, but we've also got our unknown X. So what we then do, work out the bits in the brackets again. So that's going to be 36.5, and we've got 23 plus 16 plus 1, that's 40, and we've over here got 58.5 plus our unknown X. So then we can work out this side here. So 36.5 plus 40 gives us 76.5. And on the other side, we've still got our 58.5 and X. Then to work out what X is here, all we need to do is 76.5 minus our 58.5. Because obviously, if the sum of all of these chemicals has to add up to the sum of all of these chemicals, we know everything on the left is 76.5, so if we subtract what we know from the right, the 58.5, then all we're left with is X, so that will give us X. Now if we work that out, what we end up with is, and just bear with me while I just use a calculator because even my head isn't working too well today, and we get an answer of 18. I'm sure some of you got that quicker than I did. So X is 18. Now if they were to then go on and ask us what chemical that could be, then obviously we can have a little look and see what's missing from this side on that side. And hopefully on that we can see that we've got the sodium, so they're already there. We've got the chlorine, that leaves us with 1 hydrogen, 1 oxygen and a second hydrogen. So if we think about it, H2O is going to be our chemical, because oxygen has a mass of 16, each hydrogen is 1, and that's the chemicals that we've got, and that equals our relative formula mass of 18. Okay, your turn. Have a go at calculating the mass of compound X, and if you get that done, see if you can work out what compound X is. Write your answers in your book. If you still need a bit more time, hit pause on the video. Last thing to have a go at then are the plenary questions. Again, if you're working up to a grade 5, one's on the left, beyond a grade 5, the one's on the right. And as always, you can find the answers to those on my website, and the link is just coming up in a moment. I'd suggest hitting pause on this video now to have a go at doing these. So pause now, answer those questions in your book, and then head on over to check your answers. As always, answers to the plenary can be found on my website. The link is on the screen at the moment, and you can also find some additional work if you want to keep practicing. Don't forget to join us again same time next week for our next triple chemistry lesson.